Alright everyone, today I just wanted to get a head start on the 3.3 notes, and you can see that we are going to be covering an idea called a linear inequality. So just to review, when we're talking about an equation, that means we have an equal sign. When we are talking about what makes something linear, I usually say, and this is kind of, it's not the official definition, but I always like to say, hey, we can write that in the form y equals mx plus b. Lots of different ways to define something that's linear, but I think that's what we're most familiar with. And if I think about what makes something an inequality, well, you see something like a greater than symbol or a less than symbol, or maybe you see those with a line underneath. And we can even say does not equal. That's technically an inequality as well. If you think about what the word inequality means, it means unequal. So we're going to start with something that we know, and that would be graphing a linear equation. So this is a linear equation. We should be very good at graphing a linear equation. I think the easiest way to graph it is to make sure that y is by itself so that we get it in this form. In this case, if I have x plus 2y equals 10, I would subtract the x to the other side, and then I would divide everything by 2. So we would be looking at the equation negative 1/2 plus 5. Remember, there's a negative 1 in front of that x. So when I divide that by 2, I have negative 1/2, and when I divide 10 by 2, I have 5. So the reason I like that is because now we're in y equals mx plus b form. And that's nice because I can see that my y-intercept is 5. So I know that I have a point at 5. And my slope is negative 1/2. So to find another point, I would go down 1 and over 2. And I would just graph that line. So we've done that a ton. I think we're pretty familiar with that. So I'm going to switch things up a little bit. Instead of a linear equation, something with an equal sign, now we're going to take a look at a linear inequality. So if you look here, first of all, I know this is an inequality because we don't have an equal sign anymore, this little greater than or equal to symbol. But really, I know it's linear as well because it's x plus 2y. It's the same thing as what I had up here, except we're replacing that equal sign with an inequality. Now, when I try to graph the solutions for a linear inequality, it's not just going to be the line. There's going to be a whole shaded region. When we have linear inequalities, we usually have an infinite number of solutions. In order to show the solutions, you would need to shade an entire region of the coordinate plane. Well, first things first, we need to graph this. So I'm initially going to treat it like the line y equals negative 1/2 x plus 5. I know that if I get y by itself, here let me back up, if I get y by itself, we're going to be looking at this inequality. So to graph this inequality, I'm just going to first pretend like that inequality sign is an equal sign. So we know how to graph that. Put a point at 5. Go down 1 over 2, we just did this, and make a line. But really we have to graph the solutions, and there's going to be an infinite number of solutions, and we're going to need to shade where those are on the coordinate plane. So I want to go back and look at this inequality right here. This is saying that y is greater than or equal to this line. So here's my line. I need to shade where the y coordinates would be bigger because the alligator is eating it, bigger than the line. Well, the y coordinates will be bigger when they are above the line. So I'm shading the area of the coordinate plane that is above the line. If I were to pick a point anywhere in this shaded region, like this point, that's at 8,7. If I plug an 8 here and a 7 here, it makes the inequality true. If I were to plug in the point 3,8, so a 3 here and an 8 here, it would make the inequality true. So any of the points in the shaded region, and there's an infinite number of points in that shaded region, would make this inequality true. That's why we have an infinite number of solutions. So sometimes you might be asked to identify one possible solution to the linear inequality, and that just means, pick a point in the shaded region. It can be any point as long as you're sure that it's in the shaded region. So I always like to be like extra sure. So to be extra sure, I might come up here at 10, 10. But if you weren't sure, you could check yourself. Plug in a 10 for x and a 10 for y. I'm going to have 10 plus 20, which is 30. 30 is indeed, sorry, you couldn't see what I was doing. 30 is indeed bigger than 10, so I know that 10, 10 is a possible solution. It's not the only solution, it's just a possibility. Alright, so let's flip this over. And I have another situation. I have the linear inequality of 3x minus 4y. I've got to graph the solutions. Well, before I can graph, I need y to be by itself. So I would first subtract x to the other, 3x to the other side. And then I would divide by 4. Now, negative 4. Now, when you divide by a negative, you have to flip the inequality sign. Divide the negative 3 by negative 4. Actually, this will be a minus. And divide the 4 by negative 4, and that's going to be a minus 1 there. So that tells me I have a y-intercept at negative 1. And I'm going to go up 3. 1, 2, 3. And then over 4. And there's my other point. Now, the interesting thing here is when I connect these points, I'm actually going to use a dashed line. Because this inequality does not have a line underneath it. So we can't actually include the line. That's why we have a dashed line like that. It's kind of like using an open circle on a number line. But I need to graph the solutions. This is saying that my y values need to be less than or smaller than the line. Well, in order for the y's to be less than, they would have to be below the line. So there's my shaded region. Any point from that shaded region, any of these points, if I just start picking some, would make this inequality true. We are asked to identify one possible solution. So one possible solution could be, let's just pick, okay, that would be it, 6, 0. That's what we think is a possible solution. If you're not sure, plug it back into the original. And so this would be 18 minus 0, still 18. 18 is bigger than 4, so it works. All right, and that's all I've got for today.